I have two apples. Although they look identical and probably taste the same, one is more expensive than the other, specifically this one, because this one is organic. The question is it worth to pay more for food simply because it is organic? What does organic really mean? And what's really the difference between these two apples? The study today that we're going to talk about helps explain some of these questions. Let's jump right into it. What's up, everyone? My name's Henrik, and today I'm breaking down another clinical trial. Specifically, we're looking at insecticide exposure with people who ate organic versus non-organic produce diets. Specifically, it's the effect of a 24-week randomized control trial of an organic produce intervention on pyrethroid and organophosphate insecticides. It was published by Dr. Cynthia Curl and others at Boise State University with work from the CDC in July of 2019. There's been huge debates on whether paying 20% more for organic food is worth it as compared to conventional non-organic produce or food. Because organic food typically has less or no preservatives, it lasts for significantly shorter periods of time, and people want their food to last longer. But this organic food isn't genetically modified and isn't grown with synthetic insecticides or pesticides and herbicides. Nearly everything in the grocery store can have an organic version. Specifically, organic means that plants or substances within that food have been grown on soil that has not had prohibited substances applied to it for 3 years before harvest. So like organic bread has been made with organic wheat. Organic beef comes from cows that ate organic food and specifically weren't given antibiotics or hormones. Additionally, organic food cannot be genetically modified. Nearly all synthetic pesticides, herbicides, and insecticides are prohibited, and this includes the two insecticide classes discussed today, pyrethroids and organophosphates. Specifically, pyrethroids are a synthetic version of pyrethrin, which naturally comes from chrysanthemums, the flower. So pyrethrin is allowed, while the synthetic pyrethroids are not. The main hypothesis of today's trial is if we eat conventional produce versus organic produce, are we exposed to more pesticides? If so, how much more, and does that matter? Is that significant to our health? Let's jump right into the study. This study was a single-blinded randomized control study over 24 weeks that enrolled 20 pregnant women from Boise, Idaho in the United States. The women had to be consumers of a fully conventional, non-organic diet and had been pregnant for less than 4 months. Pregnant subjects were specifically looked at because exposure to insecticides can have direct effects on the fetus. The subjects were asked a series of questions to identify if there were any non-dietary sources of insecticides to control for that confounding variable. Each study participant was given $20 a week to purchase produce over 24 weeks, and the researchers made sure that half the women received organic and half received conventional food in a sort of complicated way that is explained further in the actual paper. The women didn't know if they were eating organic or conventional food, so it was single-blinded. The study primarily looked at urine analysis, and an average of 23 urine samples were collected for each subject over this entire study period. The urine was analyzed for 4 metabolites or breakdown products of organophosphate insecticides, and 3 metabolites of pyrethroid insecticides. If you consume a chemical, it's not going to come out the same chemical. The body acts on it and breaks it down. So you have to measure that broken down form, which is what they did here. All samples were actually analyzed and run by the CDC, the Center for Disease Control in Atlanta, Georgia. All participants kept a food diary and recorded all the produce they ate throughout the entire 24-week study period. Based on the food diary, only 60% of produce eaten by the organic group was actually organic, but the conventional group had less than 3%. So technically the organic group wasn't entirely 100% organic, but it was still significantly different from the conventional group. It's important to note that this was the first study to intervene and look at organic versus non-organic diets, as opposed to purely observational where people just told you what they eat and analyzed urine over 6 months. This study also looked at urine over 6 months, which hasn't been done in an interventional study, so it's more representative of someone's lifestyle. Additionally, this was a newer study, published within the past 2 years. The types of chemicals used in food are constantly changing and advancing, so older studies that are realistically more than 5 years ago might not apply or be as applicable. With the study methods, let's jump into what the study actually found. Looking at the results of this trial with the 7 metabolites measured, the trial ended up excluding 4 of these metabolites, because in both the organic and conventional groups, they were only detectable less than 30% of the time. So it improved the strength of the study to exclude those and only look at the results that were solidly detected. That led to looking at 1 pyrethroid marker, 3 PBA, and 2 organophosphate markers, PNP and TCPY. 3 PBA was the only one to have statistically significant results, meaning it had a p-value of less than 0.05, specifically 0.03 in this case. And the conventional group had more 3 PBA in their urine compared to organic. Looking at actual values, the median for the conventional was 0.95 micrograms per liter and was 0.27 for the organic group, so a significant difference. The values looked at were geometric averages per month compared between groups over 6 months. One thing to note about this trial is that the trial only had 20 people, so it's pretty small and can't be completely representative of the entire world. Also, participants were pregnant women, and a lot of other factors could be going on there with how the body processes this insecticide. Although I don't think so, I'm not a professional, it's technically possible. Finally, the study only looked at organic produce, not other organic foods like beef or meat. It also only looked at insecticides, not pesticides, GMOs, antibiotics, or other interventions. There are also online things that I've talked about, washing your produce carefully to get chemicals off. This study didn't talk about washing, so maybe washing could remove pesticides or insecticides. We really don't know. So now that we have these results and we know that the conventional group had higher levels of 3 PBA, what does that mean? One might think that's bad, right? Have more insecticides in your food. You don't want that. But is it worth paying 20% more for organic food? Like, is there a significant difference in the outcomes of that? The study didn't talk too much about the effects of 3 PBA besides the effects it could have on a fetus, but it didn't really talk about like the mother themselves, not the fetus. So we have to look at another study for this. A study in April 2021 did a cross-sectional trial, meaning it looked at a bunch of different variables and looked for correlations between those variables and 3 PBA levels, and it specifically looked at cardiovascular disease, heart disease. They looked at a bunch of different variables like education, sex, income, medical diseases, and so on for over 6,000 people and their respective 3 PBA levels and tried to draw correlations. The average PBA level in this new cohort was 0.41 micrograms per liter. Comparatively, the conventional group in our study had nearly double this value, so the average was much lower than the people who only ate conventional produce. In this study, diet quality, as defined by pure nutrient intake, not looking at organic versus not, that was not significantly different when it came to PBA levels. However, concentrations of 3 PBA were higher in participants with diabetes. They were also higher in heavy drinkers, people who had a higher body mass index, BMI, or higher urinary creatinine. And urinary creatinine can indicate kidney problems sometimes if it's really high. Higher 3 PBA levels was also correlated with a higher risk of cardiovascular disease, specifically looking at 0.52 versus 0.40 micrograms per liter. Cardiovascular disease in this scenario was defined as coronary artery disease, heart attack, congestive heart failure, and stroke. When looking at stroke specifically, not in this big group of diseases, there was not a significant correlation. The cardiovascular portion was ran again with different models controlling from creatinine, age, sex, level of education, diet, smoking, and BMI, and it still represented a significant result, where increasing levels of PBA, as broken up into 3 tertiles, were linearly related to cardiovascular disease and coronary heart disease. In conclusion, higher 3 PBA levels were correlated to a higher risk of cardiovascular disease. So asking the important question, why does this matter? We have to know this, right? Well, eating conventional produce as opposed to organic caused significantly more exposure to pyrethroids that leave behind the metabolite 3 PBA. Higher 3 PBA has been at least associated with diabetes and various cardiovascular diseases. You can't say that 3 PBA causes cardiovascular disease, but you can say that there's a relationship between the two. The 3 PBA levels found in our main clinical trial were much, much higher than this cardiovascular disease trial, so that's something to note as well. The basic results of this trial are a group eating non-organic food had higher levels of an insecticide as opposed to a group that ate organic food, or 66% organic food. This higher level of insecticide has been correlated with cardiovascular disease, and these are the results of this trial. I'm just here talking about updated research. I'm not really recommending one thing or another, so it's your choice whether you want to move to organic, eat more organic food, but this is just the research that's come out, and I'm just here talking about it. But that's really all I had about these trials that we talked about today. Don't forget to like, comment, subscribe down below. If you have any interesting clinical trials or topics that you've come across, feel free to throw them down in the comments and I might review it. I've also thrown down the link of the paper so you can go read it. There's also all the references and studies I talked about are also down below for this video. I hope you guys learned something and have a good one. Thanks.